In example 14, the phrasing of the sentences in the question is getting rather complex. In such a question with complex sentence structures, we need to analyze each sentence carefully and extract the maximum mathematical information to solve our problem. Let's analyze the very first statement. We are given that the sum of the first 100 terms of an AP, meaning S100, is 10,000. So we have this. When we make use of our knowledge of arithmetic progression, the Sn formula, we know that that will let us have Sn equals to n over 2 bracket 2a plus n minus 1d. Applying n as 100, we will have n over 2 2a plus n minus 1, that's 99d, equals to 10,000. And when we simplify this, it gives us 2a plus 99d equals to 200. So that's our very first equation. We will proceed to the second sentence that says the first, second, and fifth terms of this arithmetic progression, meaning the original arithmetic progression, are 3 consecutive terms of a GP. Now that is something quite a mouthful, right? So we will ask the question, what is the first, second, and fifth term of an arithmetic progression? Now from our knowledge of AP, we know that that can be represented as A for first term, the second term will be A plus D, and the fifth term will be A plus 4D. So we're given that these 3 terms are 3 consecutive terms of a GP. What does consecutive mean? We know that it means that from the first term to the second term, A plus D, we should be able to get it by multiplying by the common ratio R. And from the A plus D to A plus 4D, we should be able to get it by multiplying by the same common ratio R, since the 3 terms are consecutive terms of a geometric progression. From here, we will know that if we represent the common ratio R with A and D, we can write common ratio as the second term A plus D divided by the first term A. That gives us a common ratio, and the common ratio can also be given by A plus 4D, the last term, divided by the term before it, which is A plus D. So this is important for us to deduce from the second statement. From this information here, we can cross multiply the equation that I've written down in red, and that gives us the following equation here. This one. Expanding and simplifying, we will end up with this after factorizing. Now from this equation, we can see that we will obtain D equals to 0 or D equals to 2A. We must be careful here with the reading of the question again, because we haven't finished reading the question, remember? So We get back to the question we read. We are supposed to find the first term A and the non-zero common difference D. So the key here is non-zero common difference. Now, that being said, we know that D cannot be 0. Therefore, our first answer, D equals to 0, has to be rejected over here. That leaves us with only D equals to 2A as the second equation. Since we are asked to find the first term A and the common difference D, we need two equations, and we exactly have the two equations in A and D from equation 1 and 2. Solving these two equations simultaneously, we will be able to obtain our A equals to 1 and D equals to 2. Now, that's the end of example 14. Thank you.